We are recording. Watch what we say. Chem 128A, today is 18th of February, 2021. It's a very special day because we are learning about nomenclature of alkanes. It's very important. So we're talking about alkane. I'm just going to use a colloquial word, naming. Name your alkane. Don't procrastinate. You got an alkane, you must name it. Okay, so we talked about those 10 alkanes, and then I was going to talk about configuration, but we had a break of a day. Let's kill the nomenclature of alkanes fast, and then we'll get to that complicated part, which is kind of cool. Okay, so what I'm going to do is I'm going to we have all the methane, ethane, propane, butane. So let me just write that down. Okay, so methane, CH4, ethane, C2H6 or CH3CH3. Either way is fine. Propane, that. Butane, that. Pentane, hexane, heptane, octane, nonane, it looks different. No, it's good. Decane. Okay. When you have just a simple straight chain alkane, then it's easy to name them. But realize that they can be branched. There can be things attached to those alkanes. Okay. You could have a methyl group sticking out, CH2, CH3 sticking out. You could have a branch of the branch and stuff like that. So we need to learn how to name the branches. Okay. So let's learn that very quickly. It's going to go faster than the Chem 8 class because you guys know more and we delve deeper. So I'm going to just erase this because let it be just in the video. Okay, it's not that important. So I'm going to assume that there is going to be a long alkane chain on the right side. That's the mother alkane. That's the parent alkane chain. That's the big guy. Okay, then off of that big strand or trunk of the tree, we will have different branches sticking out. Okay. We're just going to use this as a scaffold. Don't start panicking that I'm going to ask you to name that molecule. I don't even know how to name that long chain. It's going to be whatever. Okay. I'm just going to use it as a scaffold. Okay. So the first branch that I'm going to use will have only one carbon. Okay, it's just going to have only one carbon, and that's going to be a CH3 group. So when it's almost like methane, but not methane because it lost one hydrogen to be attached to the mother alkane trunk, the main alkane body of the whole molecule. So it's just a substituent. So when an alkane, it was a whole entity, okay, as it was a molecule, we call it methane. Okay, when methane becomes just a group in a bigger molecule, it loses its identity. It's not a methane anymore, it's just a substituent or a branch. So it used to be an separate individual entity, but now it's just part of a bigger molecule. Okay, then what we call it is methyl. METH, it's important that you learn it the right way. We call it methyl. The ANE becomes YL when it's a group, when it's a substituent, part of another molecule. So let's keep practicing. We can use the stick diagram for 2-carbon chain. That's the side chain, okay? So if methane 1-carbon hydrocarbon becomes 1-carbon branch, it's called methyl. Then what should this purple guy with 2 carbons be called? What should it be called?
Ethyl.
Ethyl. This is important. That's ethyl. Excellent. Okay, next. What should that be called?
Propo.
Proto.
Propo. Okay, because it's got 3 carbons. Every end, every bend is a carbon. Now, what if you have 3 carbons, but arranged in a different way? Not like long straight chain, but a branch, like a little garbage picker, like a thing, like a little prong. Okay, this is still propyl, but it's called isopropyl. One word. It's important. It is one word. The reason I'm stressing on it, you will see why soon. So if it is branched but 3 carbons, it's called isopropyl. Whenever you see that V or the prong shape at the end of the chain, it's something iso. It's iso something. Next. What should that be called?
Butyl.
Thank you. Okay. Let's see if you can get it. What should that be called using what you have learned so far?
Isobutyl.
One word. This is butyl, 4 carbon, but not isobutyl. There is a special name for it. I'll just tell you what it is. It's called sec-butyl. Two words separated by a hyphen. Very important. We will see why it is so important in a second. It's called sec-butyl. There can be one other butyl group. You can use your fingers. It'll require 3 fingers to show it. It resembles the body part of some bird that we eat quite a bit. Does anybody want to give me a finger gesture that looks like this group? It's still a butyl, but not straight butyl. It's not isobutyl. It's not sec-butyl, but
Third butyl.
third butyl. What does it look like?
Yeah, like that.
Chicken foot. I always say it looks like a chicken foot. Third butyl, 2 words separated by a hyphen. I'll just draw another group just for the sake of it. I don't know. How about Then the next contender, pentyl. 1, 2, 3, 4, 5. It's going to be pentyl. All right, let's start practicing some nomenclature. Okay, nomenclature of branched alkanes. I'm going to just cover this area. That's going to be protected. Okay, that's that discussion. This is another discussion, the different branches, and this is another discussion. Okay, let's start naming. So we're gonna talk about nomenclature of branched alkanes. That's the topic right now. Okay, you guys want to take a look at the board and just settle down and make sure that you guys are on top of it. The names of the straight chains, the names of some of the very critical components, like some branches that we're going to be dealing with through this semester and probably in the next semester. I'll try to be quiet for like 5 minutes, 5 seconds, 10 seconds, 15 seconds. Okay. All right. Let's start with the first branched alkane. I'm going to use 2 colors and pretend. If you already have read the book, try to control your urge and your itch to answer. Let's see if you don't know exactly how to do it. I want those of you to kind of predict like how to name this molecule. Okay, as if you don't know. Okay, don't pretend to be not knowing. But then if you really do not know exactly how to do it, then try to attempt. This is a weird situation, right? If you really know the answer, don't answer. Okay, you got the point. When it's a methane, you cannot have a branch. When it's an ethane, it makes no sense because when you have a branched ethane is propane, right? If you put a methyl group on a propane, ethane, that's propane. It makes no sense. It's, it becomes the next guy. So the branching starts to make sense starting from propane. So let's start with propane. So that's propane. What if we have this molecule? If you really know how to do it, try to control your urge and not answer. But if you don't know exactly how to go about it, you want to take a shot. How would you name it? How would you name this molecule? And I have used some color coding. So that's black and the branch is red. How would you logically proceed to solve this problem? Something. That's really very telling. Something. Anybody wants to take a shot at it? What's the black thing called? Can we call it the red thing and the black thing? Do you know what I'm saying?
The black part would probably be iso.
No. Okay, I know what's going on in your mind. And this is Cassandra. Okay, Cassandra, I think you're on the right track. When you're imagining the black part, don't imagine the red part. Okay, what is this straight chain called?
Propane.
It's propane, right? So let's write down propane. When you're thinking about the straight chain, don't think about the branch. Yeah, I can see exactly how the confusion can come. That's a very legitimate confusion. So let's call it based on the black part, it's propane. What if I say that then you name the branch? Let's imagine that the red part is the branch. How should you call the branch? Look on the right. Methyl. So it's bad planning, Shantanu. Okay, it's methyl propane. We can call it we can find the trunk of the molecule, the main trunk, main part of the tree, and then we can call it, it's an oak tree. But then we can say, well, it's got a branch. So we call it whatever, like a foot long branch. It's a foot long branch oak tree, something like that. Okay. So we find that the main trunk of the tree, we name it, find the branch, we name the branch. There is little more to it. So those of you who know that there is something missing, just hold off for a second. Okay, that's methyl propane. Good. Let's do the next molecule. Using that same logic, what should you call that? Use the same logic.
Methyl butane.
Methyl butane. Awesome. It's good. Something is missing. Hold off. Don't get too agitated. Speak up.
Methyl
Butane. Butane.
Methyl what?
Butane.
Pentane.
pentane.
Pentane. This is what you need to catch up during the weekend while you're having fun. Okay, when it comes to methylpentane, things start getting a little sketchy. And that's why we need to introduce a third factor when it comes to naming a branched alkane. Yes? Excuse me. That's methylpentane, right? What about this? This is also methylpentane. How do you solve the problem? If you know the answer, try to control yourself. Don't answer. Let's see if someone who is being exposed to this concept for the first time, try to have her or him take a shot at it. How do you, if you stumble upon this problem in your job, Starbucks decides to make you name their, I don't know, the branched, I don't know, lollipop or something. You know, they have different ways. And how do you name it? They want you to name it like this is like a slug, and this is like a, I don't know, like a bird with a little beak from the front. How do you name them? What's the easiest way to designate like the difference between this dude and this guy?
Do you add numbers?
We add numbers. How do we add numbers? I mean, so are you saying that we number the molecule from branch to the body or the entire trunk of the molecule first? Like this? Now the question is, we can number it left to right or right to left. The green numbering, left to right, purple numbering, right to left. Which one is makes more sense?
Left to right.
Left to right
Left
makes
to
more
right.
sense because it gets to a smaller number, right? So we can call this guy 2-methylpentane. That's the way to go about it. Perfect. This is a perfect way to do it. And you are Edgar. Good job, Edgar. Then if this is 2-methylpentane, what should this guy be?
3.
3-methylpentane. Excellent. So even though it's redundant, it really doesn't make much difference. We put that number. So it's going to be 2-methylpropane, 2-methylbutane. Make sense? So let me just do one thing so that you guys know exactly what we are talking about. That's this one. That's that. So that you don't get confused. Okay, let's do one more. I think we have room for that. Let me teach you one more detail about naming molecules, naming this sort of species. Let's draw the same thing here, pentane. Little smaller, maybe a little bigger. Let me draw it upside down. Okay, pentane. How would you name that guy? So, what species this is based on the trunk of the molecule? It's a pentane. And unfortunately, this guy has two substituents, two branches, and the branches are called methyl. But there are two of them. How do you tell the audience or whoever you're texting about what you're learning today that there are two methyl groups of this pentane trunk? How do you say two methyl? How do you say it?
Dimethyl?
Dimethyl sounds great to me. So it's some sort of, it's dimethyl pentane. But the funny business is you need to specify where those methyl groups are. How do you do it? Should we number the trunk?
Yes.
1, 2, 3, 4, 5. So what should we write on the left side of the D? Where are the methyl groups? What's a logical way to go about it? What's your logic says?
2 and 4.
2 and 4. Shall I say 2 and 4? Or what's the easier way to do that without using the word and?
Even? They're only even numbers.
No, because that could be trouble. I'll tell you why that could be trouble.
Comma,
Sorry?
a comma between.
Sounds good. 2, 4, no space. 2, 4 hyphen dimethyl pentane. That makes sense. Perfect sense. Let me see if I can squeeze in one more compound here. So that's this guy. Okay, let's draw one more. Sounds like a cat in pain. What should that be called? Using that same logic. Keep going.
2, 3.
2, 3 hyphen
Dimethylpentane.
dimethyl perfect. Stare at the board. I'm going to take a snapshot and then we will continue our discussion. I'm going to block the camera for a second, so excuse me. Okay, got it. Take a look at the board. Straight chain alkanes 1 through 10. All the important functional groups, the alkyl branches, and some examples in the middle. It got a little clustered, like little busy in the middle, but I think you can figure it out. I've also like have used a border so that you don't get too confused. Make sense? There is not much to learn here. It's like going through a laundry list. The bottom line is before Tuesday happens, before 12:30 happens, we are not going to be meeting on Zoom on Tuesday. You guys are going to just go straight and start taking the exam starting from 12:30. I don't know if it's going to go until 1:30 or 1:45. I'm probably going to make it available for the whole time. 12:30 to 1:45. You just go on Canvas, figure out how I want you to take the exam. Take the exam, and that's it. You're done. If you're done in 15 minutes, you're done in 15 minutes. Okay, that's the deal. So no Zoom meeting. I'm going to send you guys an announcement anyway. Not much to ask. There might be some questions in your mind, but hold off until we go through the next cycle of discussion. Then it'll probably get clear. Okay. All right, let's erase the board. Yeah, I'm going to erase this too. Let's take it to the next level. When you have two different branches, I'm going to keep that for a while. That's the line of control. Okay. All right. Let's do it. Let's do this one. Then what we're going to do is once we solve this guy, we're going to start writing down some rules of nomenclature. Okay. So if we are going to work on this, let's use color coding. So when you stumble upon something like this, a branched alkane which has two substituents or two branches, the word, I think somebody in Chem 8 asked me a question. What does branch and substituent mean? I think I confused some of them. So the word substituent, I will tell them on the next class, same as branch. This is the more formal or appropriate word in the world of chemistry. This is like the colloquial word. Okay? Branch is same as substituent. Substituent means substitution. When you're substituting something. So you are basically, there is a hydrogen here and there is a hydrogen here. You are substituting the hydrogen with a methyl group. Make sense? That's why it's called substitution. It's not just a plain and simple alkane chain. You are substituting different small hydrogen atoms with bigger alkyl chains. These are alkyl chains. This is an alkyl group. This is also an alkyl group. The alkyl substituent itself has a substituent. It could have been an ethyl substituent. On top of that ethyl substituent, you put another substitution, which is the methyl. So in principle, it's a methyl ethyl group. Actually, there is a way that we do the nomenclature that way, but I think I'm going to skip that. I don't really know if you're going to, well, we might actually get into a trouble because the MCAT or some of the competitive exams might have that in there. Let me think about it. I might introduce it not today, maybe on Thursday of next week. Okay, I'm going to just color it one color so that you guys are not too confused or agitated. I'm going to also remove the hydrogen. Okay. So when it comes to naming a substituted alkane, okay, I think the first thing to do would be to find the trunk of the tree. The black guy is the trunk of the tree, and then you have a red substituent, and then you have a green substituent. So tell me first, what is the longest trunk of the substituted alkane look like? Count. What is it?
Octane.
It's an octane. What would be the next logical thing to do when you look at the substituents? You have a funny branch and you have a simple branch. What should we do? What should we do about them? We should name them, right? What is this guy called? And what is this little stick called? What is the little green guy called? Look up.
Methyl.
It's a methyl. And this is called a what?
Isopropyl.
Excuse me. I don't have COVID. I'm just sneezing. It's called isopropyl. So we can call it methyl isopropyl octane. Excuse me, I'm just having this funny feeling. I think it's the allergy. We can call it methyl isopropyl octane or isopropyl methyl octane. If you know the answer, control your urge to answer. Let others try who haven't been exposed to this business yet, okay? Should we go with the size of the group or should we use alphabetical order? Like take into consideration the I and the M. What makes more sense? Which way should we call it? Methyl isopropyl octane or isopropyl methyl octane? Anybody can answer. If you know the answer, just say it.
Methyl isopropyl octane.
Why, Nathan?
Because the methyl branch is it's like the lowest number to the going from right to left, then compared to going from left to right.
Oh, you're saying okay. I see your logic. No, that's great. This is a good thing to ponder. So the numbering happens this way. Are you saying that? What am I doing? 7, 9. I need to learn my elementary school stuff first. Okay. So Nathan, are you thinking that because methyl is coming to the numbering business first, it's being picked up first, so it should be written first? Is that your logic or am I missing your logic?
Yeah, that's my logic.
That's your logic? Okay. Your numbering is perfect, but the logic is not right. Not because you're wrong. We could have done it that way, but I think the scientists thought that it would probably be better to put them in alphabetical order. But the numbering doesn't change according to the order. The alphabetical order does not dictate the numbering. Numbering is done in a way that you get to the branch first. So your numbering right to left is perfect. But we go with alphabetical order. So we're going to say isopropyl first. Sorry to disappoint you, but this is the convention. We're going to say something, a number isopropyl hyphen a number methyl octane, and the numbering will be the numbering that we have done so far. So this guy is going to be number 4 and this guy is going to be number 2. So it's going to be 4 isopropyl 2 methyl octane. That's the rule. So let's write down the rules. I'm going to erase this part because I think you guys know what we're talking about there, substituent and this thing. So rules of naming. I don't have space for nomenclature. That's my excuse. Okay, number 1. rule number one, when you see a branched alkane, what should you be doing first? What should you, if you're writing up an app or a program and you're writing, like you're trying to teach, like the software, like you're trying to develop some kind of artificial intelligence to name branched molecules. Actually, Chemdra does it. That's how I got so bad after using it for like 20 years before I came here. Then I had to relearn nomenclature. So if you're teaching the computer what to do first, what should you be telling? What should you be writing? What should be the first line of code? Do what?
You number them?
No, before you number them,
You name the main group.
before you name the
You
group,
look for the longest chain.
look for the longest chain. There you go. Identify. This is a big deal. I will tell you why this is a big deal for you for Tuesday, because I might try to trick you. I will try to trick you. So we're going to practice a few problems like that. Make sure that you don't fall in the trap. Okay. Find the longest chain. Identify longest chain. Exclamation point. Not that we should be excited about it. You're like, why exclamation point? What's wrong with this person? Okay, number two. I would not number it at this point. I would do the next important thing. Somebody has already mentioned it. What should we do? What should we do next? We got the longest chain. Then we look at identify what?
Second or the other chain.
What is that other thing? Branches.
Branches.
Substituents. I'm going to use the word branches because it's smaller. Identify branch or branches and name them. Isopropyl methyl. Next. What should we do next? Number the trunk. Number the longest chain appropriately, left to right or right to left. You figured that out. Appropriate direction. Don't screw up the direction. Then basically put things together. Alpha betize the branches and put things together, put it together. Okay, there may be a few little things that we are missing. We're gonna fill them in as we go along. Okay, these are the rules of nomenclature. Okay, let's try another one. I will be trying to trick you here. Okay, so pay attention. I'm going to use one color just to confuse you. It's this guy here. Okay, ready? What is it?
Decane.
Nathan, lay low for a second, for a few seconds.
Is it octane?
Joel, what did you say?
Octane?
Okay, you're saying it's an octane. And what octane?
Propyl?
Starting
Propyl? It's the
1, 2, 3, 4. 4 is not propyl. 3 is propyl. 4 is the B word.
Butyl.
Butyl. What butyl? What number? 4 or 5? Left to right or
4.
right to left? Sorry?
4.
4.
Okay. I deliberately ignored Nathan when he uttered a word, and I went with the wrong notion, not to make you feel bad, but this is a very common mistake, and especially when you are stressed out when you're taking an exam or a quiz. Okay? This is not the right answer. Nathan, you want to explain why?
There's 9 instead of 8.
9, I count 1, 2, 3, 4, 5, 6, 7, 8. How can you get 9?
No, you go 1, 2, 3, 4, and then 5. You're going to count down to the other branch.
So Ruby and Nathan, I think, saw something that we all missed it. That's the longest chain. 1, 2, 3, 4, 5, not 6, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Am I counting it wrong? 9. 1, 2, 3, 4, 5, 6, 7, 8. So Nathan, you are actually wrong.
Yeah, I just found out that I miscounted as well.
It is good. It is good. At the cost of your prestige, all of our prestige, it's good that we're going through this process, because in the beginning, when you said octane, I thought it was right, because I didn't look this way. I was thinking that way. You're just the way you thought. So this is not, it's not like rocket science and we're going to be thrashed. The rocket is going to crash. It's just learning, right? So this is wrong. This is also, the green path is wrong. Green is wrong, blue is wrong, the red is right, because it's 1, 2, 3, 4, 5, 6, 7, 8, 9. So you're right, Ruby. It's a non-end. Box 1 checked. Identify the longest chain and name. We got that down. Now, what's the branch looking like? That's your branch. Identify the branch. Okay, we identified the branch. What is the branch called? 1, 2, 3 carbons.
Ethyl.
Propyl.
Oh,
Methyl, ethyl, propyl, butyl. I'm going to drop my pen. Pentyl, then hexyl, right?
Professor, can you explain something real quick? When we were drawing those diagrams on the right of the whiteboard, what are the squiggly lines through the first?
Squiggly line, thank you. Thank you, I really appreciate it. The squiggly line means that it's the connection between the branch and the main body of the, whatever that molecule is attached to. So if this is attached to the wall, then this is the wiggly line. Wiggly line basically separates the branch from the main body of the molecule. That's all. I'm glad you asked. Appreciate that. Thank you. Make sense? Everybody? No confusion? That's all the wiggly line means. I should have explained it earlier. So this is non-N and this is a propyl group. So identify the branch and name them. Okay, we got that down. So it's a propyl non-N. Where is the propyl group? Should we number this way or this way? 5. 5, it doesn't matter. So it's 5 propyl non-N. let's do one more right here. Let's try one more. Okay, let's try. Let me try to confuse you again. I'm going to introduce another rule. You guys want to try it? What should this be called? You might self-discover a new rule. Anybody?
Heptane?
Yeah, what heptane, Nathan? Give me the whole deal. Tell me the whole name. Number, hyphen, branch, trunk. Let's start.
3-ethyl to methyl.
Okay, you keep quiet, whoever you are. Who is this? Stephanie? Stephanie, you were saying that? Don't say it again. Was that you?
Yeah.
Okay, keep quiet. Somebody else. I just want to make sure I'm not trying to mock others. I'm not trying to sound condescending. I'm just trying to tell you that this is a very common mistake. Don't do it on Tuesday. That's all I'm trying to do right now. What Stephanie was trying to say is correct, but before we get there, I want to make sure that you guys won't fall in that trap. So, is this the longest chain? That's the longest chain, right? That's 7. So 1, 2, 3, 4, 5, 6, 7. Is there another 7-member, 7 carbon chain? So this is 7. What about this? How many carbons is that?
7.
7.
Okay. One chain, this black chain has only one branch. The blue chain has 2 branches. Which one you think wins? More branch or less branch? What do you think the scientists thought like many years ago when they were trying to come up with the rules? More branches. Okay, so we will take this, the blue chain, let's make it red so that it stands out a little bit. If you guys can see it, I don't know if you can see it. We take the longest chain. If there are 2 long chains in 2 directions, take the chain that has more branches. So this guy wins. Okay, and so this is wrong. It's not isopropyl something. It's going to be methyl and ethyl group, and then we're going to be numbering it. Stephanie, you want to tell me again what you had in mind? Let me write it down here. Numbering should be happening in a way that you get to the branch first, but the priority of the groups will be according to their alphabetical order. Methyl and ethyl. Which one should be spoken first?
Ethyl.
Ethyl, okay. So ethyl should be what number? Where is the ethyl?
3 ethyl.
3.
3 ethyl, then
2 methyl.
2 methyl.
Heptane.
What? Heptane. Awesome. Okay, let me take a picture because our board is full. I'm going to block the view, sorry, for a second, a few seconds. Okay. We might come up with like maybe a couple more different, couple more rules, but we'll figure it out as we go. Okay. But otherwise, you guys think you can handle it? We should practice one more. So what I'm going to do is I'm going to erase this part. Maybe we'll keep the rules. We'll erase the molecules. Let's try one more, because I really want you to understand and make sure that you don't make any mistakes on Tuesday. Let's erase the examples and let's try one more. Okay, let's try this. Let's draw a long, long chain. There is no trick here. I'm just trying to see how you can figure it out. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, got that down. Okay, all right. So now let's try. Okay, good. Okay, we are good. Name it. Rule number 1. Rule number 1. What's the rule number 1? Tell me. Longest chain. There is no trick. I'm telling you, there is no trick. What's the longest chain?
Decane.
Decade. Done. Name it. Identify branches and name it. What's this blue guy called? Look on the right.
Sec butyl.
One word or 2 words?
2 words.
Okay. What that means is that we take B as for alphabetizing, not S. We look at the B. Okay. This guy, on the other hand, this branch is called what?
Isopropyl.
Isopropyl, one word. If it is one word, then we pay attention to the I. Okay, Numbering. Okay, so we're done with that. Number 2 job is done. Number the longest chain the correct way. Left to right or right to left? What do you guys think?
Right to left.
1, 2, 3, 4, 6, 7, 8, 9, 10. Okay, give me the whole deal. Let's start from scratch. Okay. What should be the name of this molecule?
Six bugle. 6 bugle.
6 what?
Bugle. 6 bugle.
What about, is it butyl? This is butyl. That's butyl. It's not a straight chain, it's a branch chain. And this is called sec-butyl. So you have to write sec-butyl paying attention to the B for alphabetizing. This guy will be written, this whole name will be written before this name. That's all that alphabetizing means. You're going to say sec-butyl first. Let's wait. It's going to be called sec-butyl because it's B. B comes before I. Hyphen, where is the isopropyl group? Number 4. Then isopropyl. What is it? Decane. Make sure you guys get it. I'm going to pause for 15 seconds, maybe 30 seconds. If there is any confusion, ask me right now. There is a test on Tuesday. I want everybody to do well. I mean it. I'm going to take a snapshot of the board. Let's talk about something a little different for the last 15 minutes. 15 minutes, yeah. Sorry, I'm blocking the board, the camera. Are we all good? Doing okay? Sounds good?
Yes.
Okay. Let's talk about something different. We're gonna take a little break from nomenclature for the time being. Let's take a break. Let's take a break. We will come back to it when we have to. Okay, so you have already learned that single bonds can rotate, okay? So we're going to talk about, the discussion will be single bond rotation, and very important, what it leads to, not different structure or configuration, but it leads to different conformation, okay? I'll explain what that is. If you're confused, just hold off. So you saw something interesting so far, because you could have the same formula, but you could have different compounds, right? Maybe we can talk about that very quickly. So we can have this area kind of dedicated to that discussion. Isomers. Okay. Isomers. We saw this molecule. What is this guy? 6 carbon. What is it called? It's not a trick question.
Hexane.
Hexane. So it's a hexane. What is its formula? C6 what? What's the formula? Cn H2n plus 2. So then
C6H14.
H6H14. We also saw some funny molecules. What is its formula?
It should be the same one.
It should be the same one. What is this guy's formula? Same formula. So same body weight, but different looks. Can we make another one? What is its formula? Same. It looks like one of those spaceships in Star Wars. Can we have another one that looks that doesn't look like either of them, but same formula? Let's bring the chicken foot. My favorite. Okay. They have been surgically changed from one molecule to another. Hexanes, plain hexane, 2-methylpentane, 3-methylpentane. This can be your homework. On top of the other homework, how to name this guy and how to name this guy. That could be good practice. The bottom line is all these molecules have same carbon content and same hydrogen content, but they're different. So they're called, anybody knows? Something isomer. They're one kind of isomer. Isomer means there is some similarity between them. It's called,
Structural isomers.
sorry?
Structural isomers.
Very good, thank you. They're called structural isomers. Okay? Conformations are different. Structural isomer means I am born this way, 2 hands and 2 legs. Someone takes my leg and attaches to the end of my leg. Just imagine I become more long from my waist down. Okay, my other leg becomes an extension of my left leg. Then we get 2-methylpentane. So basically configuration or structure, when it changes, you really have to break a carbon-carbon bond and make a brand new carbon-carbon bond. You need to take this guy, rip it, stick it here to get here. Rip it, stick it in the middle to get that. Rip 2 of them, stick one here and stick one here to get that. And then you rip this guy and stick it in the middle to get the chicken foot one. So you basically have to literally destroy a carbon-carbon bond, which is very difficult, and rebuild breaking bond and making bond. Okay, there is no TV serial called Making Bond. Maybe I'm not sure about. That's the deal, right? Conformations, on the other hand, are basically, I'm not going through any surgery or operation. All I'm doing is at some point my hands are down. I'm very comfortable. It's my most comfortable pose. Well, most comfortable will be laying down. This is not so comfortable, but you know, I might do this. Sometimes I might go like this. When I was younger, I used to always fold my hands in front of my chest. And that was my very well-known conformation. These are conformations. Like but that happens due to the rotation of a single carbon-carbon single bond or some kind of flipping. Cyclic molecules can flip. We will see that. It's not funny. You might think it's funny. I might think it's funny, but it's not funny because it's going to be leading to either gaining a lot of points in that cyclic cycloalkane chapter or losing a lot of points. You guys need to really focus when we talk about cyclohexane particularly. Okay? And there's a lot of flipping going on in cyclohexane. So what I'm going to do is I'm going to talk about some conformation. And we're going to start with hexane. We started, sorry, not hexane, ethane. We started this discussion, but we didn't complete. We're going to draw ethane. One side of the hydrogens, I'm going to color them blue. One side, other side, I'll color them red so that you can distinguish between them. We have like 6 minutes to cover. Okay, so on the left side, I'm going to make this bond on the whiteboard, this bond out, and this bond in. We are now dealing with 3D. When we did the nomenclature, realized that everything was 2D, or not even, I didn't even show everything. But now we are showing all the body parts of ethane, and we're showing them exactly where they're spatially. S-P-A-T-I-A-L-L-Y. Spatially means in 3 dimension. That's on the whiteboard. That's on the whiteboard. Out and in. Let's do the same thing here. We just started discussing it before time ran out last Tuesday. Okay, let's look at this model. I already built it. Okay, on the whiteboard, they're planar. On the whiteboard, out, out, in, and in. Does it make sense?
Yes.
Yes.
Makes sense, right? That's what I have drawn it. That's how it has been drawn. Okay. Now, what if I turn? Okay, it's acting funny. If I turn this, the right side, if I turn the carbon-carbon bond, carbon-carbon single bond can rotate. I rotate it by 60 degrees. So this one goes down. Okay, the right side is down. The one that is out, that's kind of pointing up. One that is in, that is kind of pointing that way. Okay. I don't know if I can leave it here and make you guys see it. It has to be a little bit taller than that. I don't think this is going to work. I'll hold it back again. Let's draw the molecule. So what I'm going to do is now I'm going to just turn. Let's say carbon 1 and carbon 2. We'll keep this side constant. We're just going to turn this molecule a little bit. Turn carbon 1, carbon 2 by 60 degrees. What happens then? Well, this is what happens. The left side, I haven't touched it. I have kept it constant. Okay, the left side is pretty much the same, but after turning, you saw what happened. After turning, the red carbon hydrogen bond is on the plane, but it's pointing down. The one that's pointing up, that's toward you, and there is one pointing up that's behind you. Okay, let's finish that one off. So this guy is now down. This is up. And this is up but behind. Okay, so this bond is behind, this bond is out, and this is on the plane of the whiteboard. Similarly, this is on the whiteboard, this is out, and this is in. Over here, this is on the whiteboard, this is also on the whiteboard. Are you guys comfortable with what we have done so far?
Yes.
Yes.
Okay. So these two are not configuration or structural variations. These are called different conformers. These two are conformers. Okay, these are called conformers, and it is a big deal. As I said, one of our research projects is all about figuring out these conformations. It's pretty cool. It's pretty cool because the conformational stability, if I am most of the time like to put my hands behind me, then I'll be less likely to shake hands. That's a pretty bad metaphor, but you might get some idea from it. My conformation might dictate my behavior or my function. So when you're trying to develop a mosquito repellent or a fruit fly repellent that's going to solve some agricultural problem by keeping some pests away, it's important how the shape of the molecule is. I'm just going to tell you something very, very important. These are side views. These are side views. I just want you to ponder, what will it look like when you look from carbon 1 to carbon 2? Your eye now is here. So just stay for 2 more minutes. If you're looking down carbon 1, carbon 2, how will the molecule look like? When you're analyzing conformations, that's the way we actually draw the molecule. What we do is we draw a huge circle, and that's our carbon 1. Carbon 2 is right behind it. We can't see it. What do we see when we are looking down this way? We see blue, blue, blue. This is the one that's up here. This guy is on my right-hand side because it's sticking out. My eye is here. So that's the outie. This is the in guy. The hydrogens on the back carbon are right behind here. You can barely see them. And we can't see the carbon number 2 because carbon number 2 is hiding. This is carbon 1, carbon 2 is in the back. Okay, same deal here. If we draw it from the front view, looking down carbon 1, carbon 2, carbon 1, carbon 2, and if we draw a big circle, okay, front carbon hasn't lost its locations. Hydrogen up, hydrogen out, hydrogen in. But on the back carbon, things have changed. This guy is now sticking down. Hydrogen. That guy is out. Out. And this is in. Okay? So it's same as that. This is same as that. And this is called Newman projection. Newman projection. When you look along a carbon-carbon bond, once again, this is carbon 1 and carbon 2 is hiding behind it. There are 2 names for it. One is called, this is like sun and moon and the earth on the same line, and we can't see the moon, or we can't see one of them. Sorry about that. We can't see one of them. Okay, so if they're hiding behind, there is a word, there's a phrase to describe when the sun is behind the moon and we can see the moon. What is it called? Quick, E-word.
Eclipse.
Eclipse. So this conformation is called eclipse. This conformation, have you ever seen motorcycles riding, like one guy is here, then the second guy is here, the third guy is here, the fourth guy is here? There's an S word to describe that pattern. ST. One motorcycle, one, second one, third one, fourth one, fifth one. There's a word for it. What is it? Anybody knows the words that describes this arrangement? Like they're farthest away from each other. They're pretty happy. Staggered. It's called staggered. That's a staggered way of riding on the highway. Okay. So this is called staggered conformation, and this is called eclipse conformation. This is better because the hydrogens are farther away. So this is much better. I'm going to take a picture of the board. I'm going to call it a day. We're going to have the test on Tuesday. I do not know if it is going to be hybrid or all free response. You can email me if you have any questions. I can meet maybe tomorrow. Today is pretty busy. I have one more class to teach. And then, or you can ask me some specific questions and I can answer them by email. Okay. Have a great weekend, and I'll post this as soon as I can. I can hang out for like 2 or 3 minutes if you have any questions. I'll put the front camera back. How are you guys doing? How many of you are still there? 11. Okay.
Thank you, Professor.
Bye, Cassandra and Tej. How are you, good Tej?
Good. Yeah.
Yeah, good to see you again. Yeah. Take care, okay? Have a good weekend. Bye. Bye, Harpreet. How are you, Harpreet? Harpreet ran away, or are you still there? Harpreet, where are you?